Hello everyone, my name is G.K.Kamat and I am the class teacher of the Computer Science and Engineering department and Division B. And now onwards I am going to teach a subject that is discrete mathematics. Okay, now we're going to learn the what is meant by the discrete mathematics or why we are use this discrete mathematics. So, discrete mathematics is used to introduce most of the basic terminology that are used in many advanced courses in computer science. So, once anyone can understood the basic terminology, then they can apply these ideas to solve the practical problems also. The topics or the contents involved in this course will support the more advanced courses in computer science and programs, such as in the areas of automata, computability, artificial intelligence, also, and the formal languages and syntactical analysis, information organization and retrieval, switching theory, computer representation of discrete structures and programming languages, and many more like this. Okay, so now we are going to learn discrete mathematics, that is DMS. So here there is your unit first, that is the fundamental structures and the basic logic. So in this chapter, now in this PPT or in this video, I am going to cover the 2 points, that are the sets and the power sets. The remaining points we will cover in the next lecture. So our first point is the sets. A set is a collection of the well-defined objects, okay, having the common or sharing some common property. So example, you can take it like a pair of shoes, a collection of rocks. Then the any example like set of all the second year computer science students of division A or division B. Then the fundamental concept of the set theory is that the membership or belonging to that set. Okay, so what belongs to that set? It is called as a member. An object of a set is called a member or element of that set. So that object we can call member or the element also. Next. So here the capital letters can be used to denote the sets. So sets can be denoted by using the capital letters, and the lowercase letters can be used to denote the elements of the set. So you can say that sets are denoted by the capital letters and the elements that belonging to that set are denoted by the lowercase letters. So see here one example of that. If an element P belongs to the set A, then we can write, how we can write that P belongs to A. So there is a symbol C here, that is P. This symbol is called as a belongs to symbol. So here P is the element of the, so we can write this in the statement or symbolical form, that is P belongs to A. Suppose the element P that does not belong to set A, then how we can denote or how we can write this? So we can write it, or symbolically we can denote it as P does not belongs to set A. So we can denote this by a symbolically like this way, but we can read it like the P does not belongs to A. And this here P belongs to set A, and symbolically we can write this in this way. So this is the example of P belongs to A, and this is the example of P does not belongs to A. Okay, then so these are all about the sets. So in earlier PPTs we have discussed that what is the set and how we can denote it, but now how we can describe or how we can specify the set. So I have covered here the two methods. The first one method is called as a listing method. So by listing method, how we can denote or specify the a particular set. So see here In the listing method is a simple method, that is we can list all the members or all the elements of the set between a pair of the braces. So that pair of braces are the curly braces. Okay, so see here one example. In the first set there are the four elements, that are 3, 5, 6 and 9. Similarly in the second set, A, B, C, D. Okay, in the third set the combination of the two, the numbers also and the alphabets also, 1, 2, A and B. Okay, like this way. So these are the members of the set A, or the elements of the set, three sets. So suppose we want to denote, or suppose we want to specify this set, then how we can denote? So we can write this P is equal to 3, 5, 6, 9. This is our first set. P is equal to, in the curly braces, the elements of the P are 4 elements. Similarly, the second way, Q is equal to A, B, C, D. Like the same way, R is equal to 1, 2, A and B. So understood? So this is the one of the method we can describe the set by using the listing method. Next, there is one example here by using the listing method how we can denote the set. So here there is one set, that is set B, and this set B contains the only two elements here. So okay, the first element is the ABC first set, comma, the another element is D. So see here carefully, the set B contains only two elements, not the four elements. Okay, because in the curly braces there is one element that is described in the another curly braces, that is A, B, C. So we can say that A, B, C, it is totally is the one element or first element of the set B. So this is first element, and comma after that D, it is the single element, that is second element of that set B. So this set B contains the two elements. Similarly, another example, there is a set C. So set C contains the four elements. So see here, the first element is the another list described in the list, that is A, B, C. This is the first element of the set C, and another three elements are D, E and F. So understood? These are the set B contains the two elements, and set C contains the 1, 2, 3, 4 elements. So set contains only distinct elements. Distinct means distinguishable or the single elements. So repetition is not allowed here. So we can say that set contains only and only distinct elements. So example is that A is equal to, represented, how we can denote this, A, B, C. But here the set A is denoted by the double A and A. So this representation is not allowed. If you can represent like this way, but still it is considered as the three elements. Suppose we denote this like this way, so anyone can understand there are the only three elements, not the four elements. So this representation is not allowed, or the recommended representation is like this way: A is equal to A, B and C. So repetition is not allowed or not recommended. Next, so our first method is the set listing method, and another method is the set builder method. So how we can denote the method by using the set builder method? The membership of the set can be described by stating the properties that uniquely characterize the elements in the set. So in the set builder method, the uniquely characterize the elements in the set. By using this property, you can define your sets. For example, if the set, suppose set S is there and it contains all the even positive integers that are less than or equal to 10. So how we can denote this, or how we can define this set S by using the set builder method? So here, see here, S is equal to, in the curly braces, this is X, and this is the symbol is the such that. X is such that X is an even positive integer less than or equal to 10. Understood? So we in this set builder method we are defining, or you can characterize the elements in the set. So this is character is there are the even positive integers and that are integer less than or equal to 10. So this is one of the method to specify the sets. So suppose this same set you want to define by using the listing method. Then how you can define? So you can define this like s is equal to 2, 4, 8 and 10. So all these integers are even also, positive also and less than 10 also. Understood? There are the two ways, listing method and the set builder method. So but in the whole textbooks the listing method is very used and recommended. Okay, next, the next point is the subset. So what is meant by the subset? Subset is nothing but the inclusion of a set. Okay, then how we can define it? Suppose there are the let A and B to any two sets. So if every element of the set A is an element of the set B, then A is called as a subset of B. Or in other words, we can say that A is said to be included in B. In other words, we can say that B includes A. Okay, in the definition we can say that A is said to be included in B or B includes A. But symbolically how we can denote it? Symbolically we can denote like A subset of B. So this is the symbol of subset. Okay, and this is the symbol of includes. So this symbol defines that A is subset of B and this is B includes A. Next, in the symbolically we can denote like this way: A is subset of B equivalent to X, such that X belongs to A implies X belongs to B is equivalent to B includes A. Okay, so how we can define the subset? If every element of A is an element of set B, then A is called as a subset of B. So now see here one example of that. Suppose there is a set A which contains the three elements 1, 2, 3. There is another set B that contains the two elements 1, 2. Another set C which contains the two elements that are 1 and 3. Now you can say that by observing these three sets A, B and C, so every element of B is included in the set A. So we can say that B subset of A. Like this way, the every element of C is included in the set A. So we can say that C is subset of A. Then here, this is subset. Okay, subset is regarding to the set, but belonging or membership is included to the members. Okay, so here B is subset. B subset is a subset of set A. C also set is subset of set A, but this is one. It is the element. So this one element belongs to set A. Okay. So why it is the B subset of A? Because B contains the one element which is also included in A. B contains the second element which is also included in A. So every element of B is included in A. So we can say that B subset of A. Like this way, the C contains the two elements 1 and 3. So C contains 1 which is also included in set A. C contains 3 which is also included in set A. So we can say that every element of C contains into the set A. So C is subset of set A. Next, equality of the sets, or how we can say that the two sets are to be said to be the equal. So there are the suppose two sets A and B. So these sets can be equal if A is subset of B and B is subset of A. Okay, there are the two conditions for the equality of the sets. Then and then only you can say that the two sets are equal. Suppose A and B are the two sets, then A is subset of B and B is subset of A. then and then only you can say that A and B sets are the equal sets. Okay, so symbolically we can denote the sets like A is equal to B, equivalent to A is subset of B, and this is the symbol. See here, this is the symbol for the and B is subset of A. Okay, so say one example. Suppose A contains the 1, 2, 4 elements, 3 elements, and B contains also the 3 elements, because the repetition of the four element is the repeated here in the set B. So B contains also 3 elements, not the 4 elements. So A contains also 1 to 4 elements, and B contains also 1 to 4 elements. So by the definition, we can check here A is subset of B and B is subset of A. So the conditions are satisfied. So we can say that A is equivalent to set B. Understood? Next example. The example of the equality, that is, suppose 5, 8, 7 contains one set 5, 7, 8. So here the order of the elements are different. This set contains 5, 8, 7 and this contains the 5, 7, 8. The order is not doesn't matter, because the element order doesn't matter. So elements contains the this set also contains 3 elements and this set also contains the 3 elements. So these two sets are the equal. Suppose if P contains 2 elements here. Okay, so first element is the 1 to 1 set and 3, and Q contains the 3 elements, that 1, 2, 3. So here the conditions are not satisfied, because P is not subset of Q and Q is also not subset of P. So condition not satisfied. So we can say that the P is not equal to set Q. So this is the sign of this equality, not does not equal to set Q. This is symbol here. See here. Okay. Next, what is the proper subset? In the earlier PPTs, we have discussed about the subset, but what is the proper subset, or what is the? It is also, in other words, you can say that it is the proper inclusion. Okay, so there are the two sets A and B. The set A is called a proper subset of set B if A is subset of B, but A is not belongs to, or A is not equal to B. Symbolically, we can say that the A is subset of B, proper subset of B. Then A is subset of B, and this is the symbol for the and A is not equal to B. So if these two conditions are satisfied, then we can say that the A is proper subset of set B. Next slide. Suppose set A, see here one example, that is, suppose set A contains the 3 elements A, B, C. Then and set B contains the A, B, C, D, E. So now check here the condition. So first condition is that proper inclusion, A must be subset of set B. So see here, the A contains the element A, which is included in B. B also included in A, and it is B also included in B. The element of A, C, it is also included in B. So we can say that all the elements of set A are included in set B. So the first condition is satisfied, that A is subset of B. Now check for the second condition. What is the second condition? Second condition is that A is not equal to B. So A contains the 3 elements and B contains the 5 elements. So we can say that A is not equal to B. So all the two conditions are satisfied. So by this example, we can say that A is the proper subset of B. And this is the symbol for the proper subset, that is A is proper subset of B. Next, what is meant by the universal set? Universal set. A set is called a universal set if it includes the every set under discussion. So universal set contains the every set. So that's why it is called as a universal set, because it includes or it contains the every set, and it can be denoted by the E letter also or U also. Then see here one example. A contains the three elements, that is 1, 2, 4. B also contains the 3, 5, 6, and C also contains the 1, 2, 3, 4. Then you can denote the universal set, that the combination of all three elements, three sets, that are 1, 2, 3, 4, 5, and 6. So repetition is not allowed here, so we can't include the repeated elements here. So by this example you can understand what is meant by the universal set, because this universal set includes set A also, this universal set U contains the B set also, and this universal set C U contains the C set also. So this universal set contains the every set under the discussion. That's why it is called as a universal set, and it is denoted by the U or U. E, I have used here the U symbol. Okay. Next,